Volumes by cylindrical shells. Suppose we rotate the region under the curve y equals 1 plus x minus x squared minus x cubed from 0 to 1 around the y-axis. If we were to use the disk method, then the volume is pi r squared times the thickness delta y. But the radius is at the horizontal distance, and so the radius is x. Because of delta y, we would need to express the radius in terms of y. But y is 1 plus x minus x squared minus x cubed. Isolate x in terms of y is going to be very challenging. And so instead of slicing the solid horizontally, we slice it vertically, parallel to the axis of rotation. And we see that we formed many shells. Each of the shell has an outer cylinder, radius capital R, the inner cylinder, radius little r. And so the volume of the shells is the outer volumes minus the inner volumes. But r squared minus little r squared can be factors as r plus r times r minus r. But r minus r is delta r, and if we were to let r equal the average of the two radii, then we can rewrite this as 2h 2r star times delta r. And so the total volume is the Riemann sum 2 pi ri hi delta r as I go from 1 to infinity. And if we take n go to infinity, this will give us the definite integral 2 pi, the integral from a to b, x times f of x dx. This is the volume by cylindrical shells method. And so the volume by cylindrical shells method is the volume equals 2 pi, the integral from a to b of the radius times the height of the shell times the thickness. And in our example, 2 pi, the integral, x go from 0 to 1, that is the enclosed region. The radius is x, the height is the function 1 plus x minus x squared minus x cubed, and the thickness is delta x, which is dx. Before we use the fundamental theorem of calculus to evaluate the integral, we would simplify the integrand, and then we use the power rule to find the antiderivative. We see that the volume is 23 pi over 30. As you can see, we take a region and we rotate it about the y-axis to form the solid. We then slice the solid parallel to the axis of rotation. Each of the slices will form a shell, and the volume of this shell is the volume of the outer cylinder minus the volume of the inner cylinders. All of these shells add up to form the volume of the solid.